How you doing, guys? Welcome to another video. Make sure you've got your proper calculator for this video, not your phone. Make sure you've got a data book as well. Let's get into it. So topic 1, volume 8, excess and limiting reagents. We look at how to determine the excess reagent and then how we can calculate an amount of a product from that. IB understandings, reactants can either be limiting or excess, we'll talk about that today, and we need to be able to work out the solutions to problems involving excess and limiting reagents. So, when a chemist carries out a reaction, the reactants are never in their exact stoichiometric ratios. That is, there's not 1 mole of this and 2 moles of that. Usually what will happen in a chemical reaction is there is some leftover reactant, while one is completely consumed, and that's called the limiting reagent. It's called the limiting reagent because that's the one that limits the amount of products formed. It runs out first, so it limits how far the reaction can go. We can think of this a bit like a dance party. If there's 14 men and 9 women at a party, and the ratio is only 1:1, no weird stuff going on, how many male-female couples can be made? Well, we can make 9 couples because there's 9 females that could have 1 male partner. That means that we have 5 blokes that are left over. So we would say that the men are in excess and the females are the limiting reagent. So the number of females limits the number of men that can dance, and there is an excess of 5 men without a partner. Let's take that to a chemical reaction. Sulfur hexafluoride is a colourless, odourless, extremely stable compound formed by burning sulfur in an atmosphere of fluorine. The ratio is 1 mole of sulfur plus 3 moles of fluorine forms 1 mole of sulfur hexafluoride. With little diagrams, you could see that the limiting reagent would be in green, and they are all consumed in the reaction. The excess reagent are the brown dots. At the end of the reaction, there's some brown dots left over, so it's in excess. Now suppose that we have 4 moles of sulfur and 20 moles of F2, which will be the limiting reagent. So a number of moles of sulfur is 4, our number of moles of fluorine gas is 20. Now just because sulfur is smaller does not necessarily mean that it's the limiting reagent. And to determine the limiting reagent, we do a simple little trick. We divide the number of moles of the reagent by its stoichiometric coefficient. So you look at the coefficient in the equation and you divide the number of moles by that number. So the sulfur would be divided by 1. The fluorine would be divided by 3 because that's the ratio in the equation. So the number of moles of sulfur, not the number of moles of sulfur is 4. Doing that division equals 4. Doing the division for fluorine is 6.67. After we do this little calculation, we can work out the limiting and the excess. The limiting will be the smaller of the numbers, while the excess will be the bigger of the numbers. So in this case, the sulfur will be the limiting reagent. It will run out first. And I can prove that fluorine is the excess by doing another little calculation. So the number of moles of fluorine needed is equal to, alright, fluorine's the thing that we want. We want to know how much of that we need to react with the sulfur. So it's a 3/1 times the number of moles of sulfur, because we need 3 times as much. So it's 3 times 4, which is 12 moles. So to react with all of the sulfur, I would only need 12 moles of fluorine. But I have 20 moles. I was given 20 moles in the question. So I have more than I need, so it must be in excess, and that means sulfur is limiting. Taking that a step further, here is an example of a problem. We have 30 grams of calcium is added to 30 grams of water and allowed to react according to the equation. So I have 30 grams of calcium, 30 grams of water. This is a typical limiting reagent because they've given us the mass of both. And that gives it away that you need to follow this procedure. Then they ask us to work out or to determine the mass of calcium hydroxide. So that is our unknown. But before we can calculate that, there's a few steps that we need to go through. The first step in any limiting reagent question is to calculate the number of moles of both of the reactants. So we need to find the number of moles of calcium. We've been given a mass, so the number of moles will be mass over molar mass. We can work out the number of moles of calcium to be 0.749 mole. I can also work out the number of moles of water. Again, we've been given a mass, so the formula would be mass over molar mass. We were given 30 grams, and we divide that by the molar mass of water, which will give us our number of moles of water, 1.66 mole. Part B says which reagent is in excess and by how many moles. So to work out which one is in excess, what we need to do is we take our two number of moles of our reactants, our number of moles of calcium, our number of moles of water, and then we want to divide those by our stoichiometric coefficients. The coefficient of calcium, 1. So we divide calcium by 1. Number of moles of water, stoichiometric coefficient, 2. So we divide that by 2. Then we determine what that value is. And we don't use this value in any of the other steps. But it helps us determine the limiting. So calcium, 0.749 because we divided that by 1. Water, 1.66 divided by 2 is 0.832. Once we've got that value, we look for the smallest number, and that tells us our limiting reagent. So calcium is limiting, water is in excess. The second part of this question says, and by how many moles? So water is in excess, but by how much? Well, I need to work out how much I need. Okay, so the number of moles of water needed would be 2 over 1, 2 times as much calcium, times the number of moles of calcium. So I have 2 times 0.749. This is how much water I need. So the number of moles of water that I need, doing that calculation and keeping that number in the calculator, is 1.50 moles. I had a lot more than that. I had 1.66, so I would have some left over. So I could work out how many moles is left over by doing a takeaway. So the number of moles of water in excess is our amount that were given, 1.66, take away the amount that we need, which is 1.5. I needed to do that calculation, which is 0.16 moles in excess. To finish off the question, it says, what is the mass of calcium hydroxide formed? Now, to work out an unknown using the ratio, we always work with the limiting reagent, the number of moles of that limiting reagent. So in this case, the number of moles was calcium, and it was the limiting reagent. So I need to use the ratio between calcium and calcium hydroxide. So the number of moles of CaOH2 is equal to, thing that we want, calcium hydroxide, 1 over the ratio of calcium, 1, so it's just the same, times the number of moles of the thing that we know. In this case, it was the limiting. So it's the same as the number of moles of calcium, 0.749. Now I'm in a position to determine the mass. Mass will be mole times molar mass. I've just calculated the number of moles. I can work out the molar mass of calcium hydroxide using the periodic table. So then I can determine the mass of calcium hydroxide formed from the limiting reagent. That is the most important part. Molar mass of calcium hydroxide is 74.10, which gives us our answer, 55.7 grams. Okay, let's review what we would have to do that calculation. First thing we need to do is to determine the number of moles of both. Then we need to divide by the stoichiometric coefficients to work out which one is limiting and excess. Once we've determined the limiting, we use the limiting and the ratio between the unknown to determine the number of moles, and then we can work out the mass. Here's another example. If 1 kilogram of lead sulfate is mixed with 50 grams of carbon and excess oxygen and allowed to react, what mass of lead will be obtained? So they've given us a kilo of one reactant, 50 grams of another, and then they've said excess O2 means that it's infinite. We have a large amount of that and we don't need to consider it. So for this type of question, first trick, make sure you've got the right units. 1 kilogram is 1,000 grams. We've got 50 grams of carbon and we need to determine how much lead is produced. So the first step, find the number of moles of both of the reactants. They gave us both reactants, so you must be thinking this is a limiting reagent question. So I'm going to use the same formula. Mass over molar mass for both lead sulfide and carbon to work out the number of moles of both of the reactants. The number of moles of lead sulfide, 4.18 to 3 significant figures for that one. The number of moles of carbon we can work out by doing 50 over 12, which is 4.17 moles. Now I probably should have had an extra significant figure in the carbon, so don't stress too much about that. I divide both of them by 1. Because that would be the same as dividing both of them by 2. They're in the same ratio. It's 2 and a 2, so I can divide them both by 1. I would get the same result. And what I will see is that the carbon is just slightly limiting, just by a tiny little bit. They're nearly in a 1-to-1 ratio, but the carbon is just slightly limiting. So then to work out the number of moles of lead, it's 2 over 2 times the number of moles of carbon, which is 4.17. And then so to work out the mass of lead, it's the number of moles of our limiting times by the molar mass of lead, which is 207.2, which gives us 863 grams. To quickly review, make sure you find the number of moles of both, work out which one is limiting, and then use that in the ratio. Okay, final example. 4.40 grams of P4O6 and 3 grams of I2 are mixed and allowed to react according to the equation. Which reactant is in excess and by how many grams? So that's taking that excess part a bit further, and that's a hard question. And then we need to determine what mass of P2I4 forms. So again, the steps. To work out which one is in excess, we need to find the number of moles of both of the reactants. We've been given the mass, so the number of moles will be mass over molar mass. And I need to work out the number of moles of both. Make sure you get the molar masses correct. So check the molar masses, check my molar masses, make sure I've got them right. I do that once I've got the number of moles of both, then I go on to dividing by the stoichiometric coefficient. So the number of moles of P4O6 is 0.0200. The number of moles of I2 will be 3.00 over 253.8, which gives me 0.0018 mole. Don't forget, it's not always the one that's the smallest number. So I need to divide both of them by their coefficients. So I divide the P4O6 by 5, the I2 by 8, and then I get a value that allows me to determine the limiting. So the value for P4O6, 0.004 mole, and the value for I2, 0.00148. That value is less than the value for P4O6, so that must be our limiting reagent. Our excess reagent is the P4O6. This question asks me to work out how much is in excess in grams. So this is a hard question. I need to work out how much of this do I need. Okay, the thing that we want is P4O6, so it's 5 over the thing that we want, over the thing we've got, which is I2, which is 8. So it's 5 over 8 times the number of moles of I2. That will tell me how many moles I need to react with all of the iodine, which is 0.00739. Now the mass of P4O6 in excess will be the difference, or the number of moles will be the difference between how much I have at the start and how much I have in excess. So the number of moles in excess is 0.0126 mole. That's how much excess I have in mole. Doing the takeaway from what we have, take away the excess. Once I've got the number of moles that I have in excess, then I can work out the amount of mass I have left over. So that means I can just do mole times molar mass, which is 2.76 grams. That's how much excess I have, 2.76 grams. So for B, what mass of P2I4 forms? So this is where I want to use the ratio between P2I4 and the limiting. So the thing that we want, P2I4, over the thing that we've got, or the thing that is limiting in this case, which is iodine. So it's 4 over 8 times the number of moles of I2. Keeping that number in your calculator, you can go back and get it, because you don't want to round off too early in these questions, otherwise you'll end up with a truncation error. So we have 4 over 8 times 0.0118. That's going to give me the number of moles of my product, P2I4, which is 0.00591 mole. Now I'm in a position to find the mass. So to work out the mass, I go mole times molar mass. Again, need to work out the molar mass from the periodic table. Make sure you don't make an error. Common error would be for students to make a mistake here. And then I can determine the mass of my product using my number of moles of the limiting reagent, 3.37 grams. This is a hard type of question, and some students would really struggle with this. So if you have to rewind the video and watch it again, please do so. Especially how to calculate the amount in excess in grams. Students find that very, very difficult. So make sure you watch it again, make sure it sinks in, and then come prepared to have a go at some questions. Okay, Volumate, some top tips. Given the mass of both reactants, that means it is a limiting excess reaction. Calculating the amount in excess is challenging, especially like that last question. Use the limiting reagent in the calculations to find an unknown, and then make sure you keep the values in your calculator. And I would really appreciate it if you don't bring your phones and use those as a calculator. They're no good because you can't keep the numbers in from a number of calculations. So bring your IB Maths calculator. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.